Hello and welcome to another episode of the Cutting Edge Podcast. I'm Dr. Eric Moore, Deputy to the Commanding General here at DEVCOM. During this episode, we will discuss data and decision making. We're happy to welcome Mr. Larry Larimer, Director of the DEVCOM Analysis Center, or DAC. Larry, thank you for joining us today. I'm really looking forward to our conversation.
Hey, Eric, happy to be here.
Pleasure. You know, this is the first time I get to sit down with you. We've been anxiously awaiting sitting down and having this conversation so we can really understand more about DAC and what you do in terms of analysis for the Army, to be perfectly frank. But in particular, it's the first time I get to sit down with you and you're not beating everybody in poker at one of the bar meetings.
Yeah, that old Pat Baker, he tries.
I know he tries, but he can't hang. He thinks because he's got foundational research under his belt that he can best you, but he can't. Hey, I'd really like to start with kind of thinking back of the history of DAC. I know it came out of three organizations that merged around 2019 as DAC stood up. Mm-hmm. AMSA, SLAD, and HRED. And I'll let you tell what those acronyms mean because I think I have it right, but I'll probably mess it up.
Okay. So AMSA, Army Material Systems Analysis Activity, was a longstanding organization, actually where all three were, that focused on system performance, kind of like it says, material systems analysis. We're great at doing that. The Army Research Lab Survivability Lethality Analysis Directorate, ARL SLAD, was the second one. Their focus was on cyber vulnerability and electronic warfare. And one of their great strengths was emulating the threat. So the cyber guys will take a friendly set of software and try to find vulnerabilities in it as if they were a threat, probing to find vulnerabilities. The EW guys, very similar. They'll jam a friendly system to see where the vulnerabilities are, etc. And then the Army Research Laboratories Human Research and Experimentation Directorate, they have a very unique set of skills, human factors, and what they do is they examine the interaction between a human and a material system in order to optimize that interaction, whether it be maybe training needed for the human or a change to the material system to make that interaction work more smoothly.
Outstanding.
So, unique tools. And the interesting thing is, from my point of view, when I first came to DAC, I looked back and I said, wow, those are three disparate organizations. Was it a smart thing to put them all together in one? And ultimately, the judgment I came to is absolutely they are the right three organizations to be together in one. And we'll probably talk about why I think that in subsequent questions.
I appreciate that, Larry. So one of the things I've noticed is you've got a lot of real estate. Every time we do a lab commander sync and bring in the other folks, you've got ranges, you've got folks dispersed at White Sands and other places. Could you just talk a little bit about your geographic footprint?
Yeah, so the headquarters is here at APG, along with the bulk of the organization, about 300 folks here. Spread across, talk about real estate, spread across about 10 different buildings that are in varying places at APG. I have an airfield that's on kind of out in the range part of APG where they blow up helicopters, which is really cool. Got to see. They didn't blow it up. They lit one on fire for me at Sage 47 a few weeks ago. What's called the M range, which is small arms range, right, where we do studies on the performance of small arms systems and the interaction of that system with the soldier. And then a set of buildings that are, there's an area called the compound here at APG, if you're familiar with that. Yes. I have 5 or 6 buildings there, and then a couple buildings kind of on the other side of post up near the post office right across the street. So then at White Sands, we have some pretty cool facilities. We have several buildings, office buildings kind of things. We have what's called an anechoic chamber, which is a huge building with a Faraday cage built into it so that you can do radio frequency jamming, GPS jamming, and some other things inside the building that can't get outside the building, because you don't want to jam GPSs, across
Right.
across half of southern New Mexico by doing tests. And then the old folks from HRED are spread all across the country. We've got some in Detroit, some in Redstone, Fort Bragg, Fort Benning, Fort Knox, and several other locations. I think there's 12 total.
Wow.
Where the HRED folks are. But they're ones and twos here and there, where there was a reason for them to be there. Either they're co-located with a PEO or co-located with a CDID or co-located with some other facility or reason for them to be there. So yeah, we are all over the place.
Is some of that due to the fact that back in the day, SLAD and HRED were part of ARL and perhaps working under RDECOM with some of the other
Yes,
RDECs in those days?
absolutely. Yeah.
Oh, wow. It's funny. I didn't realize those capabilities had transitioned. I knew about some of those capabilities from the past, but I really appreciate you
Yeah.
kind of laying that out because it's changed a little bit. But you guys are highly sought after. I hear you discuss throughout a lot of Army Future Readiness conferences and things like that.
Yeah.
And POM decisions. Which,
Yes.
So how does DAC improve the design of material solutions to the human system integration space?
Okay, well, that's a good question. I kind of alluded to it, but so their job as human factors engineers and HSI practitioners is to study, as I said, the interaction between a human and a material system and figure out what could be improved on that material system, or the flip side of that is there some training that would make that interaction go better? So I'll give you an example where recently my guys did an assessment of this sensor that was mounted on the back of a truck, and it had a huge antenna. It was like a 25-foot antenna. Well, occasionally, as you tried to bring that antenna down, it had pins that locked it in place.
Oh, wow.
And they would get jammed. And so the way the soldiers would unjam that pin is they would take a 6-foot-long iron rod, a grounding rod, and one soldier would hold it against the pin while the other soldier hit it with a sledgehammer, which was bad on a couple levels.
Oh,
One
yeah.
is if you miss with the sledgehammer, the guy holding the pin is maybe not in good shape. The other is if the pin pops out, the antenna could crash down, and the soldier holding the grounding rod is, subject to having that thing come down and hit them in some fashion. So basically, the human systems integration guys look at that and go, hey, this is not good. So the recommendation goes back to the material developer or the PM or industry that they need to redesign this thing because you're putting soldiers at risk. It's a safety hazard.
Right.
Another example recently with the M10 Booker is we found something similar with the hatch cover for the driver. And the solution that we recommended that got adapted was to replace that with the M1 latch cover because it was safer. In fact, there was a chance that a soldier could lose a finger in that
wow.
original M10 Booker thing. So we look at a system, we identify problems with a human interacting with that material solution and recommend mitigating steps or improvements to the design based on those, improving that interaction. So,
I knew aspects of that, but I didn't realize the depth of what you all do. So I think it's a good point to kind of lay out how DAC is different than the other DEVCOM centers. I'll say, as the former Kim Bio Center director, DAC, CBC, and also Soldier Center, we were kind of the smaller centers, and we did things kind of different. And,
Yeah.
We don't always like to say we're different, but you guys truly are different.
Yeah, we are even more different because the other DEVCOM organizations, ARL, Soldier Center, GVSC, C5ISR, they all are in the business of pushing the envelope in building material solutions that are going to end up someday in the hands of a soldier on the battlefield, and the soldier's going to use that piece of equipment. We don't do that at all at DAC. It's not our job. Our job is to assess that emergent material solution, and sometimes, and I think we'll talk about this later, across the life cycle of the system, to improve the design of that system. So we don't build any. What I like to say is,
you like BASF.
yeah,
huh?
yes, we don't build it. We make it better. Across the human systems integration space, cyber vulnerability, EW vulnerability, system performance, and sustainment.
You know, the beauty of that, what you just described, is that you're always going to be available to do something that the Army needs, that enables the soldiers in ways that they didn't even think about. So along those lines, I have to harken back. I had a number of your folks that worked in my building at the Kim Bio Center. I thought they worked for me.
Yeah.
You've got
Lamar Garrett.
Yeah.
You know Lamar?
You've got people all over the place working for all the different centers. I bet you some of the other directors don't realize that some of your people are there. They think that they're employees. No, I appreciate that.
They do. And when I go visit these guys, I make that point. Hey, you know this guy? He works for me.
So how does DAC improve the design of material solutions to make them less vulnerable to cyber attacks? I mean, You mentioned cyber a moment ago.
Yeah, I alluded to that earlier. So our guys do what are called cooperative vulnerability assessments and cooperative, CVPAs, cooperative vulnerability and penetration assessments. And they're done at different times during the acquisition life cycle. So, but we have what are called certified ethical hackers that will go out and try to everything they can to break into a system to find its cyber vulnerabilities. And then we do a report that says, hey, we found 24 high-risk vulnerabilities in your software and so many medium risk and so many low risk, and we recommend these mitigations to fix those. And then the PM comes back to us with something called a verification of fixes.
Okay.
To tell us, yes, this is how we mitigated these 26 high risk vulnerabilities, et cetera. And so we do that for the PMs. We do it actually for ATEC, in support of ATEC for PMs. So ATEC doesn't have any cyber testing capability. DAC does all the cyber testing in conjunction with the Threat Systems Management Office for ATEC. So we are the go-to guys across the Army to judge whether or not your software is sufficiently hardened against cyber vulnerabilities.
Wow.
So yeah, that's
But before I go into that, I just want to kind of go back into some other questions here. So when you improve the design of material solutions to make them less vulnerable to attack, say, how would you do it, say, in the electromagnetic spectrum?
Okay, that's a really good question. In a recent exercise network modernization experiment, we went up to Fort Dix and we jammed the next generation command and control network. They asked us to come jam it. Yes. And we did that because they wanted to see how the network would react to being jammed, and they wanted to, in real time, take an opportunity to try and find fixes to mitigate being jammed. So our EW threat emulation capability we use in that way. As example I just gave with Next Gen C2, but we've done that with ITN. We've done it with just about anything the Army makes that's a radio or a communication that has an RF propagation ability that communicates with somebody else. So another thing we do in that realm is we use laser. If you're familiar with looking through like a thermal lens or a night vision device, if it gets hit with a laser, it'll do what's called dazzle, which means it just turns white and you can't see anything, and the soldier's blinded effectively. So we'll have, as an example, I was down at Wismar a year or so ago, and C5ISR had the third gen FLIR there, and the contractor, I don't remember who the industry partner was there as well, and we were shooting it with this laser, and when the third gen FLIR gets hit with a laser, it's supposed to pop up a filter immediately based on the frequency of that laser, so that dazzle never happens. And the soldier, it's transparent to the soldier. They may be hit by a laser, but they don't know it because that filter is preventing the dazzle from happening. Well, the filter wasn't working right. So our guys were shooting with the laser. The industry guys were changing the software, and then they'd shoot it again and until they got it calibrated right, and then they'd move on to another laser frequency. But so we do that in the not only electronic attack, but in the directed energy realm, our EW guys do. So in that way, as an example, we're helping to make those U.S. material solutions better by hardening them against laser attack, or helping them understand what happens when they get jammed and how they can mitigate what happens when they get jammed.
So, listening to you speak, Larry, it just reminds me of the breadth of skill sets that you have. So historically, I just thought, hey, they're just a bunch of ORSAs, and but you have a lot more than that.
Yeah,
and so, and I think you're an ORSA by training as well.
Yeah.
So, and career military officer, et cetera. Could you just kind of highlight, what your workforce looks like and kind of the different backgrounds? Because I was just thinking about, you've got AMSA folks at Chem Bio Center. You've got folks, distributed throughout GVSC. And
yes. Yeah, that's a good question. So I think, don't quote me on this, but I think most of my folks are ORSAs. And I'm going to say something between 40 and maybe 45%.
I guess we're just using that acronym. I guess we should probably spell out.
Yeah, Operations Research Systems Analyst. But then I have the ethical hackers in the cyber division. They are not ORSAs. They're computer scientists, computer engineers, software engineers, folks who understand the software that they're trying to break into. The electronic warfare guys, physicists, other engineers, scientists, some technicians that work on some of the stuff that we do down there. In the sustainment realm, a lot of ORSAs, but very specialized ORSAs that understand things like reliability and maintainability and energy use, and building models and simulations that help them understand how a platform is going to use energy, how much it's going to use, and how often it needs to be refueled, and a lot of other things. In the general system performance area, material scientists. Okay, I've got this material, it's this much of this kind of metal and this much of that kind of metal, and if it gets shot by a depleted uranium round, it's going to go through, this much of it. So those folks. And then the human systems folks are generally human factors engineers, but also a variety of other human specialties.
Kind of behavioral sciences.
Behavioral science, right. Yeah.
Wow. So, during our previous under had you doing a large study for him.
Yeah.
So just out of curiosity, looking at the skill sets that you have, how do you get called to do a study like that for the under based upon?
Well, that's a good question. So we were doing two studies. Well, one was electronic warfare, and that's pretty easy to see why DAC would get called to do that. The other one was a science and technology investment prioritization study. And probably there are other organizations in the Army that could have done that, could have led that study. I think we were called on probably because we were part of DEVCOM.
Right.
But it turns out, I don't know if anyone else could have done that quite as well as we did. And I say that not out of arrogance, but because we did it, we did it in a very cooperative way. We invited the entire community, including the, what's ERDIC stand for? Engineering Research and Development Command. Yeah. Right.
Center,
ERDC,
under Corps of Engineers.
yeah.
Yes.
And the Space and Missile Defense Command and the Army Research Institute. So we had the entire S&T, Army S&T community involved and brought them along every step of the way. And if we hadn't done it that way, then there would be somebody at the end who could say, wait a minute, my equities were not accounted for, you messed up, and and therefore your analysis is not valid. So I think the reason we were the right organization to do that is because we were the guys who were going to bring everybody along, bring the whole community into it, and not leave anybody out.
No, it was a great study, and I first became acquainted with some of the tools that you all have to do analysis. So I've seen a lot of value to that. And the other thing is championing the little guys, Kimball Center, Soldier Center, DAC. The smaller centers have to collaborate more effectively because we collaboration and that kind of partnership and stakeholder group is essential to us accomplishing anything.
Yeah.
That's awesome. So I want to get back into some of the conversations we were having kind of about some of the material solutions and how you make them or sustain them. So as you improve the design of material solutions to make them easier to sustain, what are some of the ways that DAC goes about doing work like that?
Easier to sustain. Okay, so we have this sub-organization in my sustainment division called the Center for Reliability Growth. It's interesting what they do. So they'll take a system. I'll pick one as an example. I don't know if what I'm about to say is true or not, but it'll give you an understanding of kind of how they work. So let's pick the Bradley fighting vehicle. It came out in the late 80s, early 90s. And originally its reliability was not particularly good,
right,
which is kind of standard, honestly, for a new system like that. But what my guys do is they dig into, okay, what breaks on this thing most often? What breaks and has the biggest negative impact? What breaks and makes it broken for the longest period of time? And they do analysis to figure all this out and say, okay, first Cav division, these are the parts you need to have on hand for your Bradley because they're going to break most often.
Right.
And by the way, you need one of these because if it breaks, you're going to be down for the longest period of time. And if you break this, it's catastrophic. So you need to have one of these on hand too. And over time, let's say it has a U-joint. I don't even know if they have U-joints, but let's say it did. A particular U-joint fails repeatedly over time. They can go back to the manufacturer or the PM and say, look, you need to get a new manufacturer for this U-joint, or you need a better design for the U-joint. And eventually there'll be an engineering change proposal and a new U-joint, and all of a sudden the Bradley's more reliable than it was before. So in that way, the sustainment guys do the same thing everybody else, which is improve the design of a system to make it better for our soldiers to use.
I was thinking, oftentimes, from my time when I was in the Army, sometimes we didn't want to be the first to receive some equipment because we knew there was always going to be, nobody wanted to be the beta testing unit.
Yeah.
No, I can appreciate that. So kind of along those lines, as you improve the design of material solutions to increase overall performance, it seems like there's a lot of steps that you have to take in that process, whether it's coordination as well as some of the work that you previously described.
Yeah, it kind of gets back to what you're saying about, the smaller centers need to have relationships with the people that we work with so that when they encounter a problem, the first person they think of is DAC.
Yes.
So, whether it's early on in the design of something or as it's approaching operational test, or even like with the sustainment guys after it's been fielded. And by the way, the cyber guys, after something's been fielded, you got to worry about that too, because something you tested 10 years ago for cyber vulnerabilities, there's a whole bunch new vulnerabilities today than there was 10 years ago.
That's right.
So you can't just say we tested it 10 years ago and it's good to go. cyber is one of those ones where you got to do it periodically, otherwise you open yourself up for potential problems. And I think I lost the bubble a bit on your question.
No. I think you really highlighted, some essential points there. Ones that I hadn't even thought of, because you do have to periodically go back and evaluate because technology and things are changing.
Yeah.
We're getting overmatched sometimes
Threat
in
changes.
new ways,
Yeah.
right? And so, kind of along those lines, how does DAC leverage advanced simulations and modeling to predict performance of future systems and assess their effectiveness in different operational environments?
That's a really good question. It's one of DAC's fortes is modeling and simulation tools and analytic tools in general. But so we have a suite of tools we use for, and I haven't talked about that much, but across the set of things that I'm talking about: human systems integration, cyber, EW, performance, sustainment, etc. But in particular, trying to look into the future can be problematic, especially when it comes to new ideas, concepts, the kind of stuff that FCC works on, because you never know whether or not this robot that you're projecting is going to be there in 2040 is really going to be there,
right?
And whether or not the performance that you're supposing it's going to have is going to be the real performance. So, but we have modeling and simulation tools that if we make the right assumptions about the performance, whether it's a robot or an EW system or a communications unit, you can represent that unit of the future. But one of the things that we can and have to do is document the assumptions we make about that thing's performance. We think that by 2040, the robot will be able to go fully autonomous and at such and such speed and traverse this kind of terrain, etc. If you don't document your assumptions, then you're going to get to 2040 and people are going to think you are all jacked up because it doesn't do what you projected it was going to do in 2040. So that's just a pitfall or a challenge of predicting the future that we have to deal with on a daily basis. And we do it by documenting and being very transparent about the assumptions we make about system performance in the future.
It's funny when I'm around your team and we start looking at some of the algorithms and the modeling, and they start talking about, Monte Carlo models and simulations, et cetera. So it gets us deep into mathematics in ways that I've forgotten a lot, the little bit I did know once. So you talked about the future. And so, I know you're committed to, perpetual transformation across the different time frames, transforming in contact, deliberate transformation, and concept-driven transformation. And so when I specifically think about the future, how will DAC's analytical capabilities evolve to support this transformation? And what are some of the key challenges and opportunities that you anticipate? You've kind of talked about how you integrate with FCC.
Yeah, so we have this work effort called Priority Analytic Capabilities, and it's intended to look into the future and see those emergent technologies that we are challenged today to account for in our models and simulations and in our analysis. A great example is artificial intelligence. There is nobody, and I'm talking nobody in DOD, nobody in government, nobody in industry, nobody in academia that can tell you how to test AI and say, okay, it's good.
That's right.
Because there are so many variables associated with AI. But we have to be able to do that. We have to be able to assess an AI solution and say, hey, here are the problems with it that you, vendor, need to fix before it goes into the hands of soldiers. Just like everything else we do is improve the design. So we're not sure how to do that yet. But nobody knows how to do it. We're going along on this path with everybody who we can, muster to go with us to help us figure out how to do this in the future. So that's a challenge. But these priority analytic capabilities is an internal to DAC initiative to try to look into the future and see those things that we're going to be challenged to account for in our analysis and learn enough about it to account for it. So I'm going to get a little bit technical here.
That's
but
okay.
So there's
Please do.
3 elements to being able to account for a phenomenon, a battlefield phenomenon. One is, do I understand enough about the phenomenon to account for it? So AI, I'd say we understand a lot, but we don't understand enough.
Right.
The second is, can I develop algorithms that account for the behavior or of that phenomenon? And if I know enough about it, then I probably can develop algorithms that will account for it. And the third one is data. Can I develop data or obtain data that is relevant and credible that I can use in those algorithms to account for that phenomenon? So that's kind of the framework that we use when we look into the future and say we got to be able to analyze AI.
Right.
Do we understand it enough? Do we have enough knowledge? Can we develop algorithms that represent that in our models and sims and other tools? And then is there going to be credible data that I can use in those algorithms that account for the phenomenon? So I'm not sure at all if I answered your question.
No, you 100% did. Well, it also gave an opportunity for folks to peek into the mind of Larry Larimer to understand, kind of the challenges that he faces as he leads his organization. And you do that not only for DEVCOM and Army Futures Command, but for the Army in general. So, no, I really appreciate that. So with that, Larry, thank you so much for joining me today to talk about data and data decision making, as well as, all the different aspects of many things that DAC does. I won't say all, but many. So thank you once again. And it's first time. Oh, I see the hat over there, because the signature for Larry Larimer is that nice hat that he wears. And I was saying, it's the first time I sat down with you and I had your hat on.
Yeah, it keeps the sun off my head.
Well, that's great. And thanks, everyone, for listening in. And be sure to check out the next episode of The Cutting Edge.
Thanks, sir.
It's my pleasure.